My name is Brad Askew, and I am the Director of Channels for Secure Infrastructure and Services. And I'm here with our CTO, Chuck Paolillo. And we're going to talk to you about OpenStack on IBM Power. Because with all the changes in IT right now, it's getting tough to keep track of everything that's going on. But OpenStack has established itself as, it's given itself a firm foothold in the industry while all of this is going on. And as some of you may or may not know, OpenStack runs almost exclusively in an x86 environment. However, when OpenStack is combined with IBM Power, some interesting things happen. So that's what we're here to talk to you about today. So, in a moment, Chuck is going to come up. He's going to talk to you about OpenStack. He's going to review some of the benefits of it. We're going to also go through IBM Power. And then we're going to look at the IaaS Managed Open Cloud, which is our cloud. IaaS stands for Secure Infrastructure and Services. Then we'll look at supported infrastructure as a service workloads. And that should leave us a good 10 to 15 seconds for questions afterwards. But of course, we're here all day, so we're available to talk to you. So right now, I'm going to turn it over to Chuck.
Thanks, Brad. I'm Chuck Paolillo, as Brad said. And let's get into talking about OpenStack. So OpenStack is a cloud management framework. Basically, you can look at it as IT in a box or data center in a box. It's going to manage the compute, networking, and storage resources of your network or your environment. It works with many different hypervisors, so you could even be running VMware as a hypervisor layer, KVM, Ubuntu Native. There's several different ways, but to bring that all up into one management platform, that's what OpenStack gives you. So some of the benefits there when compared to other cloud management solutions, agility and cost savings. So it's a true full open source product. There's no license fees, no vendor lock-ins, since it can work with multiple hypervisors. You have the power of being able to run on community contributions and additions to the platform. And it brings together racks of servers working as pools of resources. It also offers a lot of scalability and flexibility. So compute, storage, and networking services can be grown out in a scale-out architecture. So seamlessly add resources as they're needed and just grow an environment very easily and seamlessly. It's designed from the ground up to be massively scalable, and high availability is also a key component of the platform. Security is another key aspect. It's fully role-based access controls to manage it. You can kind of split that out. It's geared well towards multi-tenant environments. You're able to keep those tenants and accounts separate and secure, as well as give different levels of access even within inside a single tenant or from the back-end management framework. So there's a lot of control there. It's also driven with APIs to integrate and provide levels of automation and security. So since you're interacting through an API, the back-end functions are very controllable and easy to secure. It also offers a layer of operational efficiency, improving the utilization and automation of resources, which all go down to improving cost efficiency. IBM Power. So this is a picture of the zoomed-in version of an IBM Power 8 processor, which is the current version of their processor technology. This processor actually came out in 2014, so it's actually a couple of years old now. It's been proven in the environment. But IBM Power processors, typically that's what runs a lot of the IBM legacy systems, which we also support, IBM i-Series or AS400, if any of you have seen or heard. Those platforms, AIX, as well as Linux on Power, and into their current mainframe environments. They're all based on the Power processor technology. So with the Power 8 processor, when you're comparing this to what you could do or what capabilities exist with versus an Intel chip, especially the same generation or even the new generations of Intel chips. This still has several capabilities above and beyond that level. What we're looking at here is a 12-core processor, but with the IBM Power Platform, it's actually SMT8, which means each core can run 8 simultaneous threads compared to 2 on Intel. So that one chip can run 96 simultaneous threads. Pretty impressive. The way it handles data going in and out is also another, key advantage to the IBM Power Processor. So it's got 512K of L2 cache right on the chip, which is a very large amount, and shared 96 meg of shared L3, and then up to 128 meg of L4 cache off the chip. So it's able to hold a lot of those processing transactions within the chip itself, and get through that workload very quickly. The memory transfer from the actual memory chips to the chip are also another place where it's able to sustain 230 gigabits per second, sustaining bandwidth from memory to processing, which is huge. Some of the other bus information is using PCI bus technology, layer 3 out Gen 3, so a lot of the standard components can be easily adapted into this architecture. It's got CAPI technology, which coherent accelerator processor interface, what CAPI stands for. So what they're leveraging that are things like GPU add-on cards that are linked directly to the processor. NVIDIA is making cards that work to offload those processing capabilities. Another interesting thing that happened in 2014 with the Power was IBM open sourced the platform. I think they're one of the only companies to ever open source one of their processor technologies. And they started the Open Power Foundation in 2014 with companies like Google, Mellanox, NVIDIA, and Cayenne with some of the founding. And there's hundreds of members now in that organization. Google was very interested in what was going on with the Power Processor, and they've actually just announced in the past couple weeks plans to build their own server hardware, which is how they operate all their Intel environments now as well, on the next generation, which is the Power 9 processor. So they've already got it in the works. The technology is open source and out there, so they're already building these systems and getting them ready to put into production as soon as Power 9 gets to the market for GA. So the roadmap, Power processors are going to continue to grow and improve drastically as you see over the next few years. Power 9 will be out next year, 2017, and we're already forecasting Power 10 to be out by 2020. So some of the benefits. This example shows a comparison between an environment running on Intel x86, all running Linux, so it's like a very even comparison from one environment to the other, and it's also running the same exact software. So native binary applications may need to get recompiled onto to run on an actual Power processor, but many of those applications have already been done, and they're included in most of the Linux distributions already onto Red Hat, CentOS even on the free side you can run on. So in this example, this is showing 4 x86 servers. They're physical servers, just demonstrating extreme workload. 2 of those are running PHP and Magenta on the front end, which is a web framework, and it's simulating a e-commerce site. It's got a DB server running MySQL in the backend and a Redis server. On the Intel side, with that setup, they were able to push about 5,000 users an hour with the transactions that they were simulating. Moving the same exact applications over to a single Power processor, or single Power system, which is an S822L. Those are dedicated to run Linux only, and that's a 2U server, so a single 2U footprint, running the same environments on VMs on top of Power KVM and Ubuntu. So they had Ubuntu Web VMs, a MariaDB, and a Redis VM. In that environment, they were able to scale the workload up to 32,000 users per hour. Same exact application. 6.4 times the performance and basically 65% less cost because they didn't have to manage those 4 servers and they were able to increase the transactions. So the processor really comes into play when you have a high volume, high transaction workload. These things really kick, and that's why Google's looking at it. Facebook, Rackspace, a lot of companies are starting to tie in and offer the open power solution or open power version of this platform. What we do, we offer managed open cloud as a service. So our cloud is powered by IBM Power Systems, as well as now the Novo x86 servers and other x86 in a hybrid environment, but also OpenStack. So we offer on-demand secure infrastructure as a service in either managed private cloud or managed public cloud. So we can build private stacks up with OpenStack, give you your own environment that you can either be carved up into multiple tenants, maybe different silos within an organization, and give them complete control of those resources. Our environment takes advantage of OpenStack and open source products, kind of reduce our costs and bring that savings out to our clients. And again, like I said in the beginning, the OpenStack, we offer a hybrid environment where we can mix power with x86. So you can bring Windows VMs, have those in on the same network, same environment, same space as an IBM Power workload. So if you have a high-end database or transactional workload that would benefit from running on a power system, that could be there, and some of the other systems that don't need the resource horsepower to run on additional x86 VMs. And we can mix and match those with a solution, or have a client come up with a solution that fits that environment. Deployments are very quick and instantaneous with templates. And with OpenStack, with Power and x86, even in the same environment, you manage it all from that same interface, that one interface. So if you pick a template, and that template was just geared towards running on Power, it would automatically deploy there automatically onto the Power system. You get that access management, and then the extensibility capabilities as they're built in and added to the environment will just be there and available for use. 24/7, 365 support and monitoring for our whole environment, and we're hosted in secure Tier 3 data centers throughout the U.S. Some types of workloads that we see coming in, we're hosting many production environments where companies just don't want that server sitting in a small closet. They don't have a data center already. They want to get into a reliable environment. This is a good way to just move that production, give you more reliability, give you those capabilities. People will also start and use us for high availabilities. Replicate out to us as an on-site protection. Test and dev environments. You want to just test even an application and bring it on Power, or you're just looking to test a new application. We can spin up test and development environments very easily. We also offer SAN-based replication and GR as a service. So you can just do backup straight to us, and then we can offer resources on a standby level. And that's for across all the platforms. So if you have any AS400, IBM I, AIX, Linux, Windows, we support all of those platforms. That's it. Thank you very much. Any questions? If not, Brett?
Yeah, if you have any questions today, our table is right over here. If this is something you would like to have a meeting about, please reach out to JKS, reach out to Aaron, and we will work with them to support you. Thank you very much.